So today we're transforming a function using different parameters. So using parameters, we're going to go ahead and see parameter A, H, and K in this instance. So just a quick review, functions, it's a relation that assigns exactly one output value for each input. Um, we are now using f of x as our function notation, and we know that parameter is a number that transforms a function into another function. And we're going to go ahead and be using g of x in this case, okay, as that other function, that new function that we're going to go ahead and see. So here is our beautiful transformation. We have these different parameters that we've been introduced to parameter k. Now here parameter k shifts our function up and down. So we got to remember that whenever it's introduced or whenever we're doing k, it shifts our function up and down. Our parameter h here shifts our function left or right. Okay, so it's going to be a little bit tricky because we're going to go ahead and be used to seeing it with a negative sign. Notice that we have a minus sign. So if in any case we're able to see that we have a function, like for example, let me go ahead and bring this out. Let's see, f(x) minus, let's see, 2. Whenever this symbol here, if it's a minus 2, we're moving our function 2 spaces to the right. Okay. Why? Because if I were to take that value out, if I wanted to know what just h equals, well, the negative is already in there. I'm going to leave that negative in there and take it out. So it would just be positive 2. Now, if in another case, let's see, f of x plus 3 would be given. Notice that this value is positive. It's the opposite of negative that's already originally given. What happens here in this case, our h will equal negative 3. Notice if I were to place negative 3 in here, as part of h, negative and negative gives me a positive. That's why it turns into a plus 3. So what happens here? Our whole function shifts 3 spaces to the left. So this one is the trickiest one. We have to pay attention to the symbol or to to our notation here, our symbol, depending if it's a negative or a positive sign. So notice if it's positive, it goes to the left. If it's negative, it goes to the right. Okay. All right. I just wanted to address that part. Now, our last parameter that we're focusing on today is parameter A. It stretches or compresses the function vertically. Remember that I told you guys the slime. If you have your slime and you stretch it vertically, what happens? What becomes? It's first a piece of mass or just a slime ball, and you stretch it out. It just vertically stretches that direction. So that's what our function, our parameter A is going to do to our graph. It's just going to stretch it that direction. All right. Let's go on to our first example. Let me go ahead and give you guys a little minute to copy this one down. We have our graph f of x equals x. We're going to be given our g of x as our new parameter, where it's going to equal a times f inside parentheses x minus h plus k. We're going to go ahead and write a new function when a equals 2 and k equals negative 3. Then we're going to go ahead and transform that function. Go ahead and copy this down, por favor. Okay, seems like you guys are ready. Let's go ahead and graph our first function. Our first function that we have here is f of x equals x. So let's go ahead and create that beautiful table. X, f of x. Who can tell me what domain are we going to use here? Anybody? So what domain have we been using so far? Our x values. There you go. Thank you, Katia. -2, -1, 0, 1, and +2. All right. So we're going to go ahead and then get our values for f of x. Who can give me the values for f of x for our function when f of x equals x? You guys can unmute yourselves as well. I need to know that you guys are awake. Anybody? Anyone about to give me this? F of x values? My function is f of x equals x. Thank you, Diego. So my values would be -2, -1, 0, 1, and 2. So all I have to do is go into my equation here. Yes, it would be the same. That's all I was trying to hear from you guys. Anybody could unmute yourselves. Okay, so let's go ahead and graph these beautiful points. So I have here, let's see, -2 is right here, -2 is over here, -1 is right here, as right there, 0, 0, 1, 1, and 2, 2. So let me go ahead and graph this function. Let's see if I can from down here. All right, thank you very much. Okay, that's the closest I can get from what I can see here. Okay, so now from here, we're gonna go ahead and create that beautiful, I know people getting dropped. That next function, okay? That next function with our new transformation. Now, notice here that we're given a new function. Now we're gonna go ahead and see g of x, okay? And g of x has to have that new parameter a that is being multiplied to f of x minus h plus k. Now we're given the value of those parameters. We're being told that a has to equal 2. So instead of writing a, we're going to go ahead and write 2. And the next parameter that we're given is k. We're told that k has to equal -3. Now, because we're not given a value for h, we're going to go ahead and say that this parameter for this example has to equal 0, right? It's not present, so we're told that h has to equal 0, okay? Or we can go ahead and just erase it, cancel it out, or not have it present in our function. So we're going to go ahead and now write that next function that we have, our g of x. So g of x here in this case equals our first that we're going to go ahead and focus on. Notice that this parameter a is multiplying our function. So if we were to follow that order of operations, we would obviously do multiplication before addition, right? So we're going to go ahead and do this first. Our g of x is going to equal 2 times our f of x. So let's go ahead and do that same for those values. Okay, so let's go ahead and do that part. We're doing it by parts. All right, so from here, let's go ahead and do this g of x, which g of x is 2 times f of x, right? So 2 f of x. We've done this before. Let me go ahead and do the next one, and the next one. Okay, so who can give me the value for 2f of x? 2 times -2. Thank you, guys. -4. Next value, 2 times -1. -2. 2 times 0. 0. The next ones, who can give me the last two? There you go. Thank you. It would be 2 and +4. So let's go ahead and graph those. I'm not going to create a line because we still have that last parameter. And remember that we said that K and H shift our graph so that after we graph our points, we're going to go ahead and do our shifting. Okay. So here it goes. We have it at -2, -4. Right here. -1, -2, right here. 0, 0, still passes through that origin. 1, +2, and let's see, 2 and +4. Okay, we've now had our graph here. Now from here, I'm going to go ahead and just continue to keep it in green so that we can see it. So it's 2, 2, 2. Okay. There you go. Now it's matching. So this here is when A is introduced, our parameter A, it's multiplying. And notice there that it is compressing, right? It's stretching vertically. Now, from here, we can go ahead and lastly introduce that last parameter, -3. So what does that last parameter do? Well, we know that it's shifting either left or right or up and down. So we had said that this, basically this parameter K shifts our function up or down, right? So since it's negative, it's going to shift our function down 3 spaces. So every point that we have now here already graphed, we're going to go ahead and shift it down 1 space, 2 spaces, 3 spaces. 1 space, 2 space, 3 spaces. 1 space, 2 space, 1, 2, and 3 spaces. 1, 2, and 3. 1, 2, and 3. So this function here, if I were to graph or grab this line for the equation, I have now graphed that beautiful function of g of x. And let me go ahead and write g of x nice and pretty so you guys can see it. Notice that f of x is what? X. So I'm going to go ahead and substitute that value. So now we have g of x equals 2 times f of x. F of x is just x by itself in this case, minus 3. And we can go ahead and check that out. Notice that it's a linear function, or it's a linear, we have to have that y-intercept of -3 and the slope of +2, up to over 2, up to over 2. I mean, up to over 1. So this is what we consider our parent function. From here, we can go ahead and apply everything else. And you can go ahead and do that last step if you want to your values. You can go ahead and do that 2 f of x minus 3, which in this case will give you that -7, which is right here. And that negative, let's see, -5. Yep, right here. -3 The last one would be -3, -2. Yeah, -2. 1, 2. And sorry, -1. And the last one, +1. And those points are existing there. Okay. So we focus on the multiplier first. Then we focus on shifting our function depending on what the next parameters are. If it's either, if k is present, then we shift up and down. If h is present, we shift left or right. So this is our last function. Any questions on this one? Okay, you guys are ready for the next one? All right. Let me go ahead and if you guys need me to come back to this, I can go ahead and come back. Let me move on to the next example. Okay, here goes number 2. Example number 2, we're going to go ahead and graph f of when x equals x to the power of 3. We're going to go ahead and be given that new g of x, that new transformation function, where we have a times f of x minus h plus k. In this case, we're going to go ahead and be transforming our function when a equals 1/4, h equals +5, and k equals +3. Go ahead and copy this one down, por favor, so you guys can have it. Okay, let's go ahead and do this. We're going to go ahead and first graph that function, f of x equals x to the power of 3. We're going to go ahead and continue to use our beautiful domain from -2 to 2, and then from there apply the parameters, right? Apply the transformations. Let's go ahead and create that table. Let me go ahead and do it in blue. So here is our x, here is our f of x. In this case, we have, let's see, x to the power of 3. So we have -2, -1, 0, 1, and 2. Let's see, who can give me the value for -2 for my f of x? Notice that it's to the power of 3. If f of x is -2, -2 to the power of 3. Thank you, Ayla. -8. For the next one, f of x minus 1 equals -1 to the power of 3. This would be -1. Thank you, Luis. Katia, thank you. The next one, I'll do that one. 0. And the next two, 1, +1. Thank you, Katia. And the last one, 8. Thank you, Katia. Awesome. So we were able to complete this. We know that it is a power of 3, so it'll give us that that function. Let's see, -2, sorry, and -8. So it's all the way down here. -1, 1, 0, 0, 1, 1, and 2, +8. So let me try my best here to graph this. Eek. There you go. My beautiful cubic function that I've graphed so far. All right, so let's go ahead and apply now our parameters. Let's go ahead and see. We have g of x equals a multiplying f x minus h plus k. Notice this time, I want you to look at our original function, f of x, and notice that our x is, uh, it has an exponent, right? It has an exponent to the power of 3. And I want you to notice that it's directly outside of our function or wherever our variable is. And our variable is within the function here. So what's going to happen, we're going to go ahead and write that parameter or that degree of 3 directly outside of our f of x minus h, because that's where our variable is present, right? Now, let's go ahead and substitute those values for our parameters. We said that a is 1/4. So this is 1/4. We have an h. H is positive 5. And we have a k. K is positive 3. Okay. If we were to follow order of operations, yes, we would definitely do h first because it's within our parentheses. We do grouping first. However, we already know that h is going to move our function, the entire function, to the right 5 spaces. Why do we know that? Because whenever we did it individually, no matter what our graph was, because it was already inside, it just shifted our function left and right. So we don't necessarily have to calculate this parameter in order for us to find what's happening to it. The same goes with k. K is moving our function, what makes it go up or down. Since it's positive, it's going up 3 spaces, right? Now, the one that we really need to focus on, it's that multiplier, this one. So what's happening here, it's multiplying our value or every x that we have by 1/4. In reality, it's dividing by 4, but it's multiplying everything by 1/4, which means that we need to focus on this function first. So let's go ahead and do all of that. So let's go ahead and apply that next function. Let me go ahead and do it in red. So we're going to go ahead and do that 1/4 f of x. So here we already know what the values of f of x are. We're going to multiply each value of f of x, once we've done this, by 1/4. So from here, 1/4 times what? -8 gives me, can somebody give me that answer? 1/4 times -8. 2. Close. Super close, Katya. There you go. -2. The next one, yes, -2. Ayla, thank you. The next one would be 1/4 times -1, -1/4. 1/4 times 0, 0. And the last two, can somebody give me the last two? Thank you, Ayla. 1/4. And thank you, +2. Thank you, Katya. All right, let's go ahead and graph those first. Let's see, now positive, sorry, -4, -2, -2. -2, -2. Let's see, -1 and -1/4. This is very tiny, so I'm trying my best here. Somewhere very close to that number line. 0, 0. I'm just going to go ahead and do that circle outside. 1 and 1/4. 1 and 1/4. Let's see, 2 and 2. +2 and 2. So notice that because it was less, it was between 0 and 1, or it was between 0 and 1, that was our second case, it compressed our graph here, if you notice. It compressed it vertically. There you go. All right. Now that is our graph here. We're going to go ahead and shift it 5 spaces to the right and then 3 spaces up. So we can go ahead and do our beautiful 5 spaces first, then 3 spaces up. So from here, I'm going to go ahead and go 5 spaces to the right. 1, 2, 3, 4, and 5. And then 3 up. 1, 2, and 3. So here is that point. Here goes the next one. This one's very close to 1/4, but since it's at -1, we can go 5 spaces to the right. So it should be at positive, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Yeah, 4. I knew it was 4. And then 3 spaces up. So it goes up 1/4, 1/4, and 1/4. Very close. 0. 0 goes to the right 5 spaces and up 3. So 1, 2, and 3. Let's see, this one was at 1 and 1/4. So 5 to the right at 6, up 3, 1, 2, and 3. And the last one at 2, 5 to the right gives me at 7. 1, 2, 3, 4, 5, 6, 7. I can't see. 1, 2, 3, 4, 5. There you go. And 3 up. 1, 2, and 3. So there is our beautiful quadratic. And notice that it has been compressed because it has been multiplied by 1/4. And there is that function. So let me go ahead and move this entire function over here. Ah, there you go. Obviously, I can't move those arrows. There you go. So this is our g of x. Once it's been shifted. All right. Any questions on this so far? So remember that we do the multiplier first, and then we shift it as what our parameter h and k does. Notice that if our parameter h has that negative or that minus inside the parentheses, it's going right. If it has a plus, it's going left. And it does not apply for k. If k is positive, it's up. If k is negative, it goes down. All right. You guys have an exit ticket. Let me go ahead and save this image. Let me go ahead and clear this out really quickly. You guys have an exit ticket. Go ahead and try this one. F of x equals 2x. You have the 3 parameters. A equals 2, h equals 3, and k equals -5. Go ahead and try this one out with the same domain, -2 through 2, or -2, 1, -2, -1, -0, 1, and 2. And complete the transformation to then have g of x. Okay, this is part of your notes. So this is what I want to see completed once you guys have done the lesson. And I'll have the recording available as soon as possible.